Defining instance methods. Do you remember the .update method that we have defined a few slides ago? That update method which we defined is known as what's called an instance method. It is called an instance method because it is only able to be applied and called on instances of the class, that is, the objects. We say that instance methods are tied to instances of a class. So essentially, we are saying that each instance object that arises from a class, in our case the book class data type, will have access to methods that can be applied to instances. And those methods that are applied to instances are called instance methods. In our case, the .update method is an instance method. All book objects that are created in our script will be able to make use of the instance method update. Logically speaking, these methods that are defined within a class are really just functions in nature. We know that they make use of the def keyword and have a name, as well as take in a compulsory parameter self. Two new points that we are introduced to here is that they have the ability to have additional parameters just like standard functions and or return a value, again, just like standard functions. As an example, let us create another instance method for our class. This method will be called overdue, and it will require that we pass in arguments. Specifically, this method will calculate the total fine that is imposed for an overdue book. This method will do a few things, namely, number one, we will require a parameter to store the number of days the book is overdue. Number two, we will require a parameter to store the fine fee that is charged per day the book is overdue. Number three, the total amount of the fine will be returned to the main program via this method. We will now proceed to set up this instance method in our book class data type. Define overdue self parameter cost per day parameter number days. Self.total fine is equal to parameter cost per day multiplied by parameter number days. Return string total fine r plus string self.total fine. Look at the above method that we have defined for a second or two. Try to see what we have done. We see that we made use of the def keyword to define a new function method. After that, we supply a name for the method. Within the parenthesis, we pass in the compulsory self parameter. There are two parameters that we set up for this task. We created parameter cost per day to store the cost of the fine that will be charged per day. We created parameter number days to store the number of days that the book is overdue. Afterwards, we have defined a variable called total fine. The self.variable name approach is used when creating variables inside methods. Because these are instance methods, the self.variable name allows us to create instance variables to store the information that we provide. The total fine variable will take the value supplied for parameter cost per day and multiply it with the value provided for parameter number days to effectively provide us with the cost of the total fine, which is stored in the total fine variable. Thereafter, our method will return to us a simple string which will print the cost of the overdue book in a neat format. So our full code for our book class now looks like this. And now, we may create a book object. Book is equals to book how to train your dragon Cressida Cowell 256. Afterwards, we may proceed to call the .overdue instance method using dot notation. Let us assume that the cost per day of an overdue book is 50 cents, and this book is overdue for 3 days. We call our method as follows. Print book.overdue 0.50, 3. A print statement is required because this method is returning a value to the main program. Alternatively, you may store the contents of the .overdue method in a variable and then print that variable to the screen. Output will show as follows. Total fine 1 rand 50 cents. And thus, we are able to see that with a charge of 50 cents per day, a book that is overdue for 3 days will have a total fine of 1 rand 50 charged to it. The del keyword, extra information. The del keyword is not necessarily one that you will use in your Python scripts. However, it is good to know that this keyword and functionality exists in Python. So in simple terms, that del keyword allows you to delete any object in Python that has already been created. Logic says that in order for something to be removed or deleted, it first needs to be created. So, for example, I can create a simple string variable object in Python and then I can print this variable to the screen. String var is equals to hello there, print string var. And we will see output to the above code as follows. Hello there. And after we print and use that object, maybe there will come a time when we no longer require that object. Remember, all variables and objects that we create in Python take up space in our computer memory, RAM. So maybe you would like to clear up the space that an object is taking up in your RAM. You may simply delete that object after using it using the del keyword followed by the object name. For example, del string var, and the object will be deleted. It is good to know that there is no output or message that will be seen in the console to tell us that the object has been deleted from our RAM. But if we try to print or perform any manipulation on the object that was deleted, then we will get an error. Print string var del string var print string var. Notice that there is an error message. Looking at the previous slide, notice that we first printed the variable to the screen, then deleted it, and after we try to print it again. But Python is alerting us via an error message on the left side of the line number in the editor. Also, when we try to print the variable that has been deleted, we obtain an error in the console. Looking at the output obtained on the previous slide, we are able to confirm that after the del keyword is used on an object in Python, that object will no longer be available in our script because it would have been deleted from system RAM. Therefore, any attempt that we make to reference that object will result in us obtaining an error. Just like how we deleted this freestanding object, we also have the ability to delete objects inside functions or inside methods. For example, you can delete instance variables inside a method in the same way that we have just deleted a string object. Python memory management. This section will talk about memory management in Python. This is sort of extra information that is good to know. So we have experience with Python programming. We know that a variable takes up space in our RAM, and just about any object that is created in our Python script will require RAM to be stored. And when we use the del keyword to delete an object, we are essentially freeing up the space in our system by clearing some of the object stored in RAM. In Python, the creation and deletion of objects is managed by the Python Memory Manager. The Python Memory Manager is also known as Automatic Memory Management. The Python Memory Manager or Automatic Memory Management is one of Python's advantages when compared with programming languages such as C or C++, because this Python Memory Manager or Automatic Memory Management is what basically allows Python to automatically allocate, assign, and deallocate, unassign space in memory, RAM, automatically. Because you see, in programming languages such as C and C++, it is very common to hear stories that tell of programmers encountering errors, bugs, on which they spent several hours trying to fix, only to realize after a long period of time that the error was in fact an issue relating to memory, RAM. This problem arises from a concept known as memory creep. Memory creep occurs when system or program allocates memory but does not free up, deallocate the memory after use. So if memory creep is continuously occurring each time a script is run, then one of two things will happen. The application or program will either use all of the available system memory, or the program or application will run out of memory space and produce a runtime error. Problems associated with memory, such as memory creep, occur in programming languages such as C and C++ because programmers need to concentrate on not only the complex program or application logic but also on memory management. This is one of the factors that contribute to the differing levels of difficulty between the Python and C++ programming languages. Depending on the programming language they are working with, programmers must ensure that they only allocate memory when it is required by the program and deallocate it when it is no longer required by the program. A question we as programmers may have in mind is, why do some programmers like to manage memory allocation manually? Why not let the system or program do it automatically? Well, the answer to that is simple. You see, a variety of programming languages have been created to suit the needs and preferences of a variety of programmers, each with their own likes and dislikes. Programmers say that managing memory manually is more efficient. It allows for you to have more control over your program. Effective memory allocation that is done manually allows your programs to be faster and it leads to more compact code. Another interesting point to know is that the level of a programming language is often conveyed by the nature of its memory allocation process. It is a fact that higher level programming languages are more productive in nature as compared to lower level languages. Higher level programming languages are more expressive and have fewer errors and still meet the standards of efficiency from a programmer's modern day point of view. Because when a program language has automatic memory management, then the programmer can dedicate all of his or her focus on the application logic. A very good example of this would be the Python programming language. This, in fact, makes the programmer more productive. Issues related to poor memory management are removed from being a possibility. Python provides developers with automatic memory management. Python will assign a portion of memory to an object as and when required. When system memory is short, Python automatically looks for memory areas that are no longer in use or no longer being referenced by the program. These unused memory spaces will be cleared and freed up, deallocated, so that they can be reassigned, reallocated. This automatic Python process of allocating, deallocating, and reallocating memory is called garbage collection. So, out of this entire topic of memory allocation in Python, the most important lesson that we learn is Python provides developers with garbage collection support.